start looking today at how to balance chemical reactions. It's a really important skill in chemistry. I'm going to do this as a two-part video series. And in this first part, I want to take a look again at what all the numbers mean that we see around the different compounds that we'll see in chemical equations. So when we look at a compound like H2S, this is hydrogen sulfide. You'll notice that there's a little number 2 right after the hydrogen. That's called a subscript. Sub means below and script means the writing. So it's written somewhat below where I'd write the line that I put the letter H on. Subscripts tell us how many atoms we have of that particular type in the compound. The 2 after the hydrogen means that there are 2 hydrogen atoms. There is no number after the sulfur. When there is no number after an atom, we assume it to be a 1. Remember, we never write the number 1 in chemistry. So in H2S, there is 1 sulfur atom. So subscripts are the first thing we pay attention to when we're counting how many atoms there are. Sometimes we'll also see a large number written in front. Our large number is called a coefficient. It tells us how many groups there are. 2 H2S's means there are 2 groups of H2S. There's one H2S and another H2S. Mathematically, it would mean multiply. I've got 2 groups of 2 hydrogens. 2 times 2 is 4 hydrogens. You'll see there are 2 here and 2 here. 2 groups of 1 sulfur means there are 2 sulfurs in total. 1 sulfur here and 1 sulfur here. So mathematically, the coefficients are telling us to multiply because they're telling us how many groups that there are. The other thing we want to pay attention to are polyatomic ions, which we've learned previously come with brackets. And while I won't be asking you to write names and formulas for polyatomic ions, you still have to recognize how to count them when you see them. In the compound barium hydroxide, there is a 2 outside the brackets. It means that the barium atom is attached to a hydroxide group here and another hydroxide group here. That little 2 means there are 2 hydroxide groups. Each hydroxide group is made up of 1 oxygen attached to 1 hydrogen. In this compound, there's no number after barium, and from the picture we can see 1 barium. The 2 outside the brackets refers to everything inside of it. There are 2 oxygens and 2 hydrogens. You can see clearly from the picture 2 oxygens and 2 hydrogens. Let's practice using those rules with a few examples. In magnesium chloride, I can see that there is 1 magnesium atom and the little 2 tells me 2 chlorine atoms. In the formula aluminum sulfide, I see there are 2 aluminum atoms and the 3 after the sulfur means 3 sulfur atoms. In the formula calcium phosphate, this 3 refers only to the calcium, so I'm going to have 3 calcium atoms. The 2 refers to everything in the brackets. There's 2 groups of 1 phosphorus, so that's 2 phosphoruses. And there are 2 groups of 4 oxygens. 2 groups of 4 means 2 times 4 means that we will have 8 of the oxygen atoms. This is a great point for you to pause the video and try these 4 on your own. Pause the video here, and once you're done, press play, and we'll see how you've done. All right, let's check our work. In the formula H2SO4, hydrogen sulfate, you can see that there are 2 hydrogen atoms. There's no number after the sulfur, so that tells me there is only 1 sulfur atom. The 4 after the oxygen means I'll have 4 oxygen atoms. In CH3OH, I can see no number after the carbon, so there is 1 carbon atom. There are 3 hydrogens here and another one there. These are all hydrogens. 3 plus 1 gives me a total of 4 hydrogen atoms. And there is 1 oxygen atom. In a formula for aluminum sulfate, the 2 after the aluminum means 2 aluminums. There are 2 groups of sulfates. Each sulfate has 2 groups of 1 sulfur, so that's 2 sulfurs, and 2 groups of 4 oxygens, 8 oxygens. Finally, we have the formula calcium phosphate. Let's break this one down together. To help you visualize this, I'm going to draw what this is representing. This 2 means 2 groups of. We have 2 groups of calcium phosphate. Each group has 3 calciums. So I would have 3 calciums. There's 3 calcium atoms. And each group has 2 of these PO4 groups. So my calcium is attached to one PO4 group and another PO4 group. So this is what the group calcium phosphate might look like. Now, this is not meant to represent the actual bonding, just what we would be actually seeing. So I can see that in a grouping, I'm going to have 3 calciums, and I'm going to have 1, 2 phosphoruses, and 4 plus 4, 8 oxygens. This is in one group. But remember, this 2 up here means we have 2 groups. So multiplying this by 2, we will see 6 calciums. 2 times 2 is 4 phosphoruses, and 2 times 8 is 16 oxygens. In your work package, you have some practice on this. I'll do the first one with you. In the formula sodium carbonate, I can see 3 different kinds of atoms. Na, I know, is all one atom. That's why we have capital and lowercase. It helps me to know where one element ends and the next one begins. Carbon is the next one, and oxygen is the third. I can see the little 2 means there are 2 sodiums. No number after the carbon means there's only 1, and 3 after the oxygen means there's 3 oxygens. So we have 3 plus 1 plus 2 is a total of 6 atoms in the molecule. Complete the counting atoms practice worksheet, and then go on to the next video, balancing equations, in order to help you use this concept to understand how we can make equations be balanced.